Hello and welcome to Technically Speaking, where scientists and engineers come together to chat about a common interest, share knowledge and satisfy some curiosity. I'm Laura and I'm joined by Antonia to talk about science that astounds us, why it astounds us, and share what we know about it. So, Antonia, the idea for this episode, like a lot of the episodes in this podcast, came about because of something you saw recently. So, do you want to tell us about it?
Yeah, so I was at the Museum of Science and Industry in Manchester recently, and there was a exhibition about Stephen Hawking. It was very interesting because it was sort of a scientist who I've sort of known about my whole life, and it is sad that he's not with us anymore. But something I didn't realise was there's something that comes out of black holes, and I always thought nothing comes out of black holes, straight up. That was just fact. Stephen Hawking theorized something that does come out of black holes, and it's now called Hawking radiation. I thought that was really interesting because never knew about radiation coming out of black holes. And I did a little bit looking, and actually, it was theorized in 1974 and not properly proven with actual, what's the word, observations in space.
Ah, okay. So, my undergrad degree, now it was like 20 years ago when I studied this. But I was taught a little bit about black holes, and the one thing I remember is, yeah, pretty much what you say. It was pretty much, thou shalt not have a naked singularity, which means all black holes are surrounded by this event horizon, which is the point at which light can't escape from it because everything's sucked into it.
Hmm.
Yeah, but I also remember that some black holes can have jets, and I kind of thought that it was ejecting mass in some way at some point, but very hazy memory, right? So I looked it up and I was wrong. It's not. The black hole itself isn't ejecting anything. It's the accretion disk around it. And astronomers think it's something to do with the fact the black hole's spinning and it creates this like almost wraps sort of a gravity field or an electromagnetic field around itself, and that causes stuff to fling off. And that's what I was initially thinking about when you said stuff is given off by black holes. So apparently I was wrong about that.
Okay. Is the event horizon and is the accretion disk, is that part of the black hole, or is that just the things that we notice are around black holes and only black holes, or are they anywhere else? Because then does that define a black hole?
Oh, I think a black hole is defined by how it bends space-time, which is a phrase I've never really liked because I find it a bit meaningless unless you understand the physics.
I don't know. For me, who doesn't really understand the physics, I feel like bending space-time, yeah, I can appreciate that. I think that has a nice visual. You can just see that. Just there's space, and then no space.
Yeah, it's usually visualized as like almost like a grid that starts off as flat, and then you've got this sort
Mm,
of thing that sucks it all down into. I guess it's like a gravity well.
I think it is. I think it's an everything well, isn't it?
Yeah,
Except for Hawking radiation.
I think you're asking is that accretion disk? Is that part of it? I'm going to say it's
Mm,
not, but the accretion disk is caused by the effects of the black hole as it's
okay.
sucking stuff in. That's the point at which it probably could escape if you gave these particles some velocity, because they eat galaxies and stars and all sorts, don't they?
Black holes or accretion disk.
The black hole, yeah, and that's what
Yeah.
the accretion disk is. It's the that matter being broken up
Ah.
and moving around
Like
and
a blender. Like
pretty, yeah,
just kind of starts getting too close and then all of it just gets broken up into smaller pieces.
yeah. That's a good point. That's quite a good analogy. So I guess the black hole in that case is like the center of the blender with the
Yeah.
blades whirling around.
Yeah. See, I'm an engineer, so you have to break things down a bit more simply.
There's an inherent double entendre in that comment as well. But the Hawking radiation, I don't think I was taught anything about this in my undergrad. It was in like, but when I looked into it after you mentioned it the other day, it sounds like it's a very small amount of radiation anyway, like a millionth of a degree Celsius, or degree Kelvin, similar thing. So it's not really possible to detect it in space because you've got so many other things going on. So I guess I can see why no one's really proven this theory from 1974.
And I suppose how close would you have to be before you could detect that kind of, how sensitive an instrument would you need?
I had visions of someone flying up as close as they dared to a black hole and like taking a picture then and running away. But you're talking about like, an Earth-based sensitive detector or something surrounding our own planet.
How far away are we from that technology?
I couldn't possibly say.
Yeah.
How would you build something to be that sensitive to detect a millionth of a degree change amidst all this? I guess you just call it noise if you don't want to detect it.
Yeah, I mean, like, what's the most precise temperature measurement we can currently take? And then just imagine how, like, much of a distance we have to try and cover and detect that amongst, yeah, all the background noise, as you were saying. Hmm.
Yeah, see, if someone could do that, that would really blow my mind.
Mm,
Yeah, I'd also read, this gets even weirder, so you're quite surprised that black holes give off anything.
yeah.
Apparently, it's not just black holes that give off this Hawking radiation.
Okay.
It's something to do with quantum physics. So I think the Hawking radiation, it's not even necessarily, oh, this is where it gets really weird. The normal description is that you've got these particles that kind of split apart. You get a particle antiparticle, and one
Yes.
of those gets sucked into the black hole. But I'd also read that that is just a visual interpretation of the maths, and the maths just creates these things that you can interpret as particles, and it's just part of the equations.
Is this where we start going into the realms of where it could be a particle or it could be a wave?
Yeah, I believe so.
So it's not exclusive to black holes. Well, I think Stephen Hawking came up with the idea from studying black holes.
That's my understanding of it, yes.
Mm,
I guess it's sort of related to Heisenberg's uncertainty principle. I want to say that the interpretation of having these two physical particles is more if we have a mass or something, a particle, an electron, whatever, and we don't know exactly where it is, so it could be on one side of the event horizon or it could not be. And then something interacts with it to cause that. This is where I'm really trying to not use just standard physics terminology. I really don't want to say the wave function. The wave function collapses.
Well, there's a reason why we came up with words. It's the shorthand of the really long explanation of what a waveform is, which I might need a reminder of what the waveform is.
I could say the waveform is just maths. It was
Okay.
one of the episodes that we did with Emma a while ago. We was talking about this sort of thing, and she was like, "It's literally just a mathematical representation of the particle, and it's just a series of like sine waves or cosines or whatever."
Okay. I'll accept that as a limit of my understanding. Okay, so that's interesting because I did hear about antimatter and matter, but we could never find any evidence of antimatter because it would have been annihilated by matter. But then why did we end up in a world where we have matter? Whereas if it was even, we should have nothing. This is my understanding of the Big Bang.
But Emma's our resident physicist. It would really help if she was here for this episode because you're asking me questions that I don't have definitive answers to. But if I had to guess, like in the episode with that, it was about the multiverse and does it really exist and can we find any evidence for it? And if it's something that we don't understand the physics of well enough, we can't interact with it, I guess.
Mm,
So the antimatter could just be something that's so radically different that we have no way of detecting it. Same as we can't see inside a black hole because it sucks in all light and therefore all information. So the physics in there could be completely different and we have no way of figuring that out.
but something that could be explained is, I think, Hawking radiation, that formula incorporates a lot of theories, and it's a nice, tidy formula that physicists liked, and they thought, hey, this actually puts together a lot of theories, and the fact that, yeah, you can see it in other places kind of shows we live in that classic physics world. I want to say classic physics because it's what we sort of experience of the world, and that's how we understand physics, right?
Yeah, the classical physics is sort of like the macro scale stuff, and the quantum physics is like the really tiny stuff that we can't quite see properly. Yeah, I think one thing I find weird about all of physics is like it's pretty much just really good understanding of maths and knowing the maths well enough to say, oh yeah, that clearly makes sense and that describes the universe and therefore can predict things that we can't interact with. I guess that's probably like a really powerful thing for physicists and mathematicians that know their trade really well.
Mm. There's a fundamental about the Hawking radiation we've not discussed, which is it doesn't actually come from the black hole itself, but it comes from just outside the event horizon. So that's why I was sort of asking, what makes a black hole? Is it just the absence of nothing, or the other effects that it has around in space?
There's also the idea that black holes are very slowly evaporating, though, aren't they? Like they're gradually losing mass and getting smaller. And I didn't quite get how that matched up with the idea that they're giving off this radiation, because as you say, the radiation is outside of the black hole. If you're asking the question, where does the black hole start and end?
Yeah.
Then if they're saying this radiation is somehow linked to the fact that they're losing mass on a timescale of like billions of years, how does that fit in? Question for the physicist. Maybe Emma can tell us in a future episode.
But also, if it's disappearing, where is the mass going? If, like, all the energy, all the mass is condensed into a black hole, what happens if it's going away? That means something is leaving, or it literally isn't there anymore. Like, how is that possible?
Yeah, I assume the idea was it's putting it back into the universe that we can measure, which made me think it must be the Hawking radiation. It's converting some of its mass into this Hawking radiation, giving it back to our known universe. But then, if the Hawking radiation isn't coming from in the black hole, there must be something else going on there, something that people haven't quite figured out yet, or that I just don't quite understand because it's quite nuanced.
Maybe there are theories and we just haven't read them yet.
Just too difficult to get your head around without being like a highly competent mathematician, which I'm definitely not.
Yeah, count me out as well. But I was amazed to find that someone has kind of proven it on an artificial black hole. So there's like two things that is amazing there. A, that they've sort of proven it, and B, they've made an artificial black hole.
That does sound weird. So on Earth, there is something that is meant to be supermassive. It's probably not the right term there, but massive enough that it can suck light into it and it can't leave.
No, they didn't do it that way. They instead sort of made it analogous to a black hole in the sense that they have made it out of sound waves so much that sound waves can't escape.
Oh, like creating a sort of a sound barrier. That
Yeah,
doesn't sound right either. Sound barrier is something
because
else.
we know what a sound barrier is. Instead, they've got rubidium particles, or atoms, sorry, and they move faster than the speed of sound, so sound waves can't reach the event horizon and therefore escape the black hole.
Oh, okay. So yeah, I guess they're sort of using the concept of a sound barrier combined with the vibration of atoms. That is weird. But I suppose it also illustrates a version of wave-particle duality, I guess.
Imagine if you could have a black hole made of sound, then never have any noisy neighbors again. Perfect.
That is very true. I can see some definite applications of that. I spend a lot of time on trains trying to work, and there are people on their way for a night out.
Forget noise cancelling headphones, just mini black holes.
Does it trap all sound or just certain sounds? I imagine it would only trap something with a frequency similar to those vibrations.
It stopped. It just straight up stopped sound waves.
Yeah, all sound. Yeah, I quite like the idea of having a sound barrier that just cancels out all sound, or even better yet, selects different sounds so I can hear some of what's going on and just block out the sounds I don't like. But there's something from my undergrad degree, it's not physics, you'll be happy to know, that really astounded me when I heard it. So the other half of my degree was geology, and I did some paleontology modules as part of the degree. One of my lecturers happened to say that the event that wiped out the dinosaurs was only really discovered in the 1980s. Before then, no one really considered that an asteroid striking Earth is what wiped the dinosaurs out. And I was born in the 1980s. And I thought, well, this is a really recent discovery in that case. It's a really recent finding. Science is still evolving. We still don't yet know everything about the universe, clearly, because we don't know how black holes work.
But they're really far away. Dinosaurs were on Earth, so there is that.
But far away in time, yeah.
That's true as well. Time and space. Very difficult when it's far away in time or space.
Yeah, true. But, this is the thing that books and films are made out. Right? Jurassic Park, and the original Jurassic Park book was written in I think it was 1990. So I guess it was inspired by all this conjecture from geologists and paleontologists about what wiped out the dinosaurs.
Oh yeah, from my point of view, it's always been dinosaurs were wiped out by a meteorite. So the fact that it's brand new is yeah, quite I say brand new. New in terms of science. You know, the physics we were talking about before is even older, isn't it?
That's it, right? A lot of the fundamental physics concepts that we still use today, and a lot of like fundamental chemistry, came from like early 1900s,
Yeah.
and this is something from much later on. And I just thought, wow.
What was it that they'd actually discovered?
There were some geologists that had noticed that in the rock record that relates to about that time frame, there was a lot of a particular chemical element that isn't. There's not a lot of it on Earth, right? And there's a lot more
Mm.
comes from outer space, and it was sort of almost like a blanket surrounding all of the Earth's continents from the sound of it. And they thought, oh, this is odd. How has this thing come from space and gotten all over Earth? So they published a theory in 1980 that it must have been an asteroid that was sufficiently large enough to deposit all this material around the Earth by just hitting the Earth. It's such an impact that the asteroid sort of spewed all of its matter up into the atmosphere and then it rained back down. And I think from what I'd read, there were some people working for an oil company that had found what they thought could have been a giant impact crater in Mexico. But because they were working for an oil company, it didn't really get out into the scientific domain, so it wasn't that well known about. And it was only much later on, in the 1990s, that this huge crater was linked to this idea that something large must have come from outer space to spread. I think it was at indium or something, all around the globe.
So the thing that really put it together was finding this crater that matched what could possibly be a big enough thing that could kill all the dinosaurs.
I think so. And yeah, I did do a bit of thinking, like, how do they know that that crater was made in that time period? And how do they know it was definitely caused by an impact from something coming from outer space? And it sounds like there are various things you can look for, like certain changes in the rock, little like glassy spheres that are only caused by this sort of high pressure, high temperature event. And so a particular type of quartz. I can't remember the exact phrase. I don't know if you've read anything about quartz generated by asteroid impact.
No, I didn't actually read about that, but from my understanding of geography and how like mountains and those kind of like formations on Earth, you could kind of tell from like which way up the materials came. So I suppose they could take a slice and sort of see like it kind of is an abnormal sort of a deposit of material, whereas, you know, it might come from the bottom up. You might expect more of the similar type rock, but suddenly to have that quartz, it would kind of seem like a sudden bit of change happened.
Yeah, and there are calculations you can do based on what type of rock is above it and how thick that type of rock is to work out how far back in time that rock comes from. So these weird quartzy things, they could figure out when they were formed. Um, and I think I kind of understand how they figured out how big the asteroid was and how big a part it played. I feel like I can probably just about explain it. Do you want me to have a go?
I mean, it sounds like more reading than I've done on this, so yeah, I'd love to hear what you'd figured out.
So I think the crater itself is 150 kilometers in diameter, it's 110 miles, and it's about 20 kilometers deep, or 12 miles. But the asteroid was probably much smaller, and they figured out how small it is, and they figured out where that sort of asteroid might be in the asteroid belt that's between sort of us and Mars and Jupiter, and how fast that was likely to be moving. And it's quite a slow one, quite a fast one apparently. And that sort of gave them an idea of how fast it would be moving. So it was kind of like this, almost like a jigsaw of putting together bits of information and then filling in the gaps, and then sort of reiterating that process to arrive at information that all matched together.
Now that's surprising because what I did read was I think someone more recently thought that it wasn't as close by a rock as we thought, but actually might come from the Oort cloud, which extends beyond Pluto.
Oh, okay, so they still think it was an asteroid, or do they think it was some other type of space debris, like a comet?
No, that is a good question. I
What's the difference? What's the difference between a comet and an asteroid?
think I know what a comet is. It kind of has a repeated pattern in space, doesn't it? It kind of follows almost its own orbit, although it can be swayed by other fields, so it might change slightly. That's a comet, right?
So they're normally defined as whether they're rocky or icy, so comets are generally icy.
Oh.
But yeah, they do orbit the sun on a fairly defined path and come quite close to it. So when you can see a comet in the sky, it's some of the vapor, some of the ice vaporizing as it gets close to the sun and heats up, and that's why you can see like
Mm,
comet tails in the sky. Whereas asteroids are mostly just rock.
I see.
But I did read something that said, like, well, how did we end up striking this asteroid? Was there something, some event that caused various asteroids to collide and change their paths? They ended up in the path of the Earth or on a trajectory to Earth. And no one's entirely sure of the answer to that question. No one knows how this asteroid ended up hitting Earth.
Hmm. It's also quite amazing considering how big the impact is from something seemingly relatively small as well.
6 to 9 miles in diameter. Sounds pretty big to me.
But like 100 times in scale was its like spread of the impact.
Yeah, so apparently they think it was travelling at 45,000 miles per hour.
Okay.
I can't even imagine that.
No. Like how far away would it be before you could see it, before it would have just killed you instantly?
Good question. I guess it depends also where it is in space, right? Because I assume you can't see it unless sunlight is reflecting off it,
Yeah.
or until it gets into the Earth's atmosphere and starts heating up.
The speed of light would also have to be enough, or there would be enough time for the speed of light to travel to your eye as well before it hits you.
I think the speed of light's a bit faster than that, though, isn't it?
That is true, yeah. But I just mean there's all these things that need to line up.
Fair enough.
Well, I'm just like trying to picture how would I actually work that out, but I need a flow diagram. All these sort of things like space and science, they always seem to be sort of the first hooks as children into what's so interesting about science. For me, the first thing I was interested was space and planets and learning about all that. For some children, it's dinosaurs. I kind of know why I'm interested in space, but I don't get why other people are so interested in dinosaurs and why kids are so interested in dinosaurs.
I can't say I was ever hugely excited by dinosaurs either, apart from the Jurassic Park films, which I absolutely loved the first one when I saw it as a kid. But yeah, again, I was also quite interested in space, and at one point I did want to be an astronaut.
Oh,
Yeah, I mean, I think for me that's the idea of going out into the unknown and having an adventure, right?
I don't know what it was about planets that I think it was because it was sort of mystical and the idea that there are, where we are on a sort of rocky Earth-based planet, there were icy planets, entire planets made of gas, and that was what was interesting to me. Imagining like floating gas in space just blew my mind.
I guess for the dinosaur fanatics, it's kind of the opposite. I mean, you said they were something on Earth, right? So there's sort of this
Mm,
tangible link to home,
yeah.
albeit when the dinosaurs were around, home looked very different, I think.
Yeah, we have a lot of like scaly toys for dinosaurs, but actually they were feathery. And that's also a new bit of science that we only found out about recently, like in our lifetimes, right?
I've heard this as well. And I think because I'm so used to the representation from childhood of dinosaurs being big lizards with just leathery skin that I can't imagine a feathery T-Rex, say.
Be a lot less scary.
Exactly. You don't imagine. Well, then again, I say you don't imagine feathery things as being scary because they're kind of fluffy. But birds of prey, if you've ever been dive bombed by a buzzard in the Lake District, which I have, you run.
True. I mean, anything flying towards you of a reasonable size, yeah, it's time to run.
I do have a weird fear of being like speared in the eye by a blackbird that doesn't get out of the way in time. He's just flying along, not really paying attention, and I'm out like riding my bike or something, and we collide.
Ah, I see. I was thinking like at what speed would you have to be traveling at for a blackbird to just head on, fly into you?
Weird fear, I know. but it's there.
I mean, it's not impossible, is it? Just what are the chances?
Exactly, that bird is probably paying quite a lot of attention.
And they're, it's quite inherent to them as well to make sure when they fly, they don't fly into things.
Yeah, I was going to make a point about birds flying into windows, but I think that's because they can't quite see them because they're transparent or reflective. So I'm going to shut up.
Yeah, it's a bit of an abnormal phenomenon from their point of view. They haven't learnt it from thousands and millions of years. Be interesting when they have evolved to avoid glass.
If only they could. I feel like that's an entirely separate podcast episode. How do birds see? What spectrum do they see? How often do people walk into windows? Does happen? Oh, like big plate glass doors.
Doesn't even have to be see-through though. Like the amount of times, like I feel like it was always when I was walking to school that someone will walk into a lamppost
Hmm.
and they're not see-through whatsoever.
That is getting. I feel like we're getting completely off topic here as well.
Yeah. Accident rate of lampposts. That's another episode.
Yeah, something else that astounds us, but possibly doesn't really fit into this one. So I feel like we're just deviating and talking about random things like people walking into lampposts. Maybe that's a good place to leave the episode. So things that astound us are the discovery of what really killed the dinosaurs, and that black holes do seem to give off some sort of radiation, although we don't quite understand the details of that. So if you've got something about science that astounds you, please let us know. We would love to hear about it, and we might do it as a future episode. Until next time, thank you for listening. The views expressed in this podcast belong entirely to the person that said them. They do not represent any industry or organisation. If you enjoyed listening to these views, it would really help us out if you could rate us, leave a review and tell a friend. This podcast was sponsored by no one, but if you're interested in funding us to continue to have frank discussions about science and engineering, please get in touch.